Okay, Intermediate Math 3. This is part 2 of the Unit 4 exam review. So let's go ahead. I'll give you a problem similar to what number 7 is going to look like. It's going to look something like this. Okay, very simple. All right, so now you don't have a common base situation here. 3 raised to any power is not going to give you 11, so it's not a common base. So you're simply going to use logs here. Anytime you have to extract a variable out of an exponent, you use the log. And anything you do to one side, you do to the other. Okay, so we use the rule that says you can take this exponent and pull it out into the front like that. It doesn't have to be just a single letter or single number. It can be, that's a binomial. It could be anything that's in the exponent. Okay, now we get our calculator out and calculate the log of 3. And that's going to be 0.477. And the log of 11, and just show you how to do that. It's the log button. Then you put 11 inside the parenthesis, close the parenthesis right there, and hit equal, and that gives us 1.04. And I'm rounding, so it won't give us an exact answer, but it's close enough. Okay, so now we have to solve for x. Now it's just an algebra problem. Rather than distribute this through to here, let's just divide. You have that choice, both sides. And that gives us here 2.18. This cancels, so you have x minus 2 equals 2.18. That's 2.18. You're going to add 2 to both sides. That cancels, and you have x equals 4.18 right there. Okay? So that's your answer. And of course, you can check your work on the test by taking that number and plugging it back into x. So let's do that. And it's going to be 3 raised to the power, caret. And it's x minus 2, so it's 4.18, that's x, minus 2. Uh-oh, this calculator doesn't work. 3 raised to the power of 4.18 minus 2 equals, and I get 96.7. Not right. I made a mistake. Let me do that again. And I didn't close a parenthesis. Here, let me show you what I did. 3, well, let me do it right. 3 raised to the power. Now I'm going to put a parenthesis. 4.18 minus 2. You should always use parentheses everywhere on a calculator. Close the parenthesis. So now everything there is up in the exponent. And now I hit that and I get 10.9, which is close enough to 11. Okay? So that's your answer. All right, let's go on to number 8. And it's going to look something like this. Okay, it's going to look something like that. And again, what you want to start learning how to do is recognizing these common base situations. That 9 is a common base of 81. If it wasn't, you could see that 3 is a common base of both of them. So it's not always this number has to be a common base of that one. It could be 3, or it could be something else. Okay, but anyway, 9 is a common base, so this is equal to 9 to the first power. 81 is equal to 9 to the second power. I just put that in parentheses. That's the 81, and then the x plus 4 goes on the outside. And the rule says that we can take this exponent times this exponent. So that's going to be 9 raised to the 1 times this is just going to be all of that. And 2 times all of this is going to be 9 to the 2x. 2 times x, and then 2 times 4 is 8. So since 9 raised to this power equals 9 raised to this power, then these two exponents have to be equal to each other. So you have 3x minus 1 equals 2x plus 8. I'm off screen. And now it's just algebra. I'm going to subtract 2x from both sides. This goes away and I end up with x minus 1 here equals just that, 8. Now I'm going to add 1 to both sides. This goes away and I have x equals 8 plus 1 is 9. Okay, and that's how you do that. I'm going to actually work a second problem for this because I realized the problem I made up is a little bit different than the actual number 8 on the test. And that could give you, so let's call this 8A, I'll do an 8B, okay? So let me pull this paper away and let me make up another problem. And this one is going to be okay, how about that? Okay, so this is also a common base problem. What's different from this from the last one is that 9 raised to some power never equals 27. 9 to the first power is 9, 9 to the second power is 81. So it never equals that number. However, there is a number that raised to some power will equal this, and that same number raised to some other power will equal this. And I think you can all see what that is. It's 3. So I can't use this as my common base as I did in the last problem. So I'm going to make 9 is going to be 3 squared. And then you have the x minus 1 on the outside. And then 27 is 3 to the third. So you kind of have to know your exponents. How do they work? Okay, you have to recognize that. So that's going to be 3 to the third power for 27, and that's going to be 2x on the outside. And again, the rule says we can multiply these two together. So that's going to be 3 to the 2 times x, and 2 times negative 1 is negative 2. Okay, so I multiplied those. Now this is 3 times 2x is 6x. Okay, and now we're back to where we were on the previous problem. Since 3 raised to this power equals 3 raised to that power, then these two exponents must be equal to each other. So you don't even need to use logs. You just say 2x minus 2 equals 6x. Subtract 2x from both sides. That goes away. And you have minus 2 equals 6 minus 2 is 4x. Okay, we divide both sides by 4. That goes away, and you end up with x equals negative 2 over 4, or negative 1/2. And that's your answer. Okay, all right, let's keep going. Number 9. And this is going to look something like this. Okay. So that looks like that. And let me give you the instruction. The instruction is you want to create, you want to expand this. That means from a single logarithm, you want to expand it out to a bunch of logarithms. That's what expand is. So I'm just going to put, that's the key word in the question, okay? And question number 9 on the test looks very much like this. So what you do is you use a couple of the rules from our sheet that when you have two numbers multiplied together, log of two numbers multiplied, you can break that out into log of A plus log of B. And this one, when you have two numbers divided inside of a log, you can break that out into log of A minus log of B. So what that's going to look like is this. We've got log, all of these are going to be log base 4s. So we're going to start with the 64. It's 64 times x squared, so I'm going to write log base 4 of 64 plus log base 4 of x squared. Again, I'm just employing that log of 64 times x squared is going to equal log of 64 plus log of x squared. That's that rule right there. Now it's divided by y to the third, and that's going to be a subtraction. So you take a, all of this that you have is a, and then the b is this. That's the a right there, and then this is the b. So it's just going to be minus log base 4 of y to the third. Okay? Now, what else do you do to that? Well, the log of base 4, 64, you can do that on your calculator using the change of base rule. So let's do that. So what that is, just this right here alone, is going to be, we're going to use the change of base rule, which says that if you have the log of x, which is something other than 10, because you have to use this rule then. So log of base 4 of 64, you put the log of 64 on the top and the log of 4 on the bottom. Okay, this y is the 64 in this problem and the x is the 4. So log of 64 on the top, log of 4. Now what's the b? The b is anything you want it to be, and we always want it to be 10, because that's what our calculator does. It does base 10 logs. So b is always 10. So this is going to be, and you don't have to write base 10, just log by itself means it's base 10, but I'm just trying to emphasize that. And that's going to be over log base 10 of 4. So you can run that on the calculator, and I'll do that down here. So I'm simply gonna, and I like to use parentheses on a calculator. I'm trying to make this so you can see it. Parenthesis, log 64, close parenthesis. Now you got to close the parenthesis twice, because you have a parenthesis right there for the 64, and then you have one out there. So you don't do that, it's going to come back with syntax error or cannot compute. So I close the parentheses. Now I'm going to divide that by parenthesis log 4. And if you don't feel comfortable doing this all at one time, do the log of 64 first, write it down, do the log of 4 second, write it down, and then divide those two numbers, okay? You don't feel comfortable doing what I'm doing. So I have to close that parenthesis, and then I have to close this parenthesis also. So it's a second close parenthesis. Okay, and if you hit that, it gives you 3. And some of you may have seen that. What a log 64 is saying is, what power do you have to raise 4 by to get 64? That's what this is saying. I have to raise 4 by what power to get 64? The answer is 3. So that's 3 right there. Okay. Now the only thing I can do with these two, I can't solve for a specific number, but I can take that exponent and bring it out front, and this one and bring it out front here. So the final answer would look something like this. 3, which is this, plus, I'm going to bring this out here, 2 log x, so that is this, and then 3 I'm going to bring out front, so it's minus 3 log, I should have put base 4 on the other one, of y. That should be base 4 as well. Okay, that's really the final answer. If you didn't do this simplification to that, I'd still give you credit for it. As long as you did the rest of this. That's what expanding means. You stretch it out, basically, is what you got to think of, okay? Stretch that out into a bunch of logs. All right, next. Do number 10. And 10 is going to be going in the other direction. It's going to be into a single log. So it's going to look something like this. Okay, so you're going to take this and go backwards, do the opposite of what we did on the last problem. So again, you use the same two rules, which are these two. So you're going to take those pluses, that plus right there, and turn it into a single log with a time sign. And you're going to take this division, this minus sign right here, and turn it into a single log with a division. So it looks like this. So the first thing you want to do is take these and go backwards and put them back as exponents there. Right there, sorry, right there. Okay, and you don't have one in front of this one. So let's do that first. So it's going to be log. Okay, so the only thing I did on this step is took that, and instead of pulling it out from an exponent in front, I went backwards. I put it back as an exponent there. I took this, put it back as an exponent. We can put that in parentheses right there, outside, actually outside, so right there. Okay, and then this one didn't need any change. Now I go ahead and use rules 10 and 11, and it looks like this. Okay, so the plus sign, these two becomes a multiplication there. Close that. And the minus sign here becomes a division of that. And that is your final answer. You can't simplify it any more than that. Okay, so that is how you do number 10. Let's move on to 11. Okay, so this one we have... Okay, so for this one we have log base 4 8. So you can get a specific number. There's no variable there. So you can do that with the change of base on your calculator. Okay, and then this one we can basically, well, let's see what we do. What we're going to do is to get everything outside of a log of base 4 is we're going to raise it to the 4th power. So you can always use an inverse of an exponential. An exponential and a log are inverses. But you got to be careful because this is not log base 10, so you don't use 10. So we're going to use this rule right here where we can take a log of x, raise 10 to that power, and get x. But since it's not a base 10, log base 10, you can't use 10 there. It's a log base 4, so you have to use 4 there. Okay, so just follow this example, and the test question won't be that hard. So what I'm going to do is this. I'm going to take 4, and I'm going to raise it to this power. You have to raise it, whatever that base is, that base has to be, in order for it to be an inverse. So these two are going to reverse each other. So that's log 4 of 8 plus 4 raised to this. And that means this, I also have to take 4 and raise it to that power. I'm raising everything, I'm turning all of these into exponents of 4. So what 4 log 4 does is it cancels these out. It's an inverse. So that brings out an 8. Again, 4 raised to the log 4 is an inverse. It cancels that out. So this becomes, there's a plus sign there, plus x minus 3. And 4 to the 6th power, unfortunately that's going to give us a pretty big number here. The one in the example won't give you a number that's quite that big. So I'm just going to do it. So don't worry, you won't end up with a number this big. It's 4,096. It's not crazy big. It's just big. Okay? All right. So now we just solve for x. We add 3. That cancels, so you add 3 to that, and that becomes 4,099 equals 8 plus x. Okay, and then I subtract 8 from both sides, and this gives me 4,091. That goes away, and that equals x. So x equals 4,091. Okay? In the problem, that's not a 6, so you won't end up with a big number like that. You end up with a small number. Okay, but that's how you do this. You just raise, you have a log of 4, you have a log of 4. The way you can get this out of that is by creating an inverse. Raising 4 to this power, raising 4 to this power, and then you have to do the same thing on the other side, 4 to the 6th power. And these just cancel out. The 8 comes out, the x minus 3 comes out, and bam, you're done with your problem. Okay, so number 11 on the test is just like that. Okay, let's keep rolling here. I tell you what, I'm going to do the last 3 on a different video because it's Thursday morning. I'm coming up close to 9 o'clock here. So you have all the way through 11. There's only 3 more problems to go. So I'll go ahead and post this before class on Thursday. And you have those. And then 11, 12, and 13 I'll finish up right after class on Thursday. And you'll have those up by noon, okay? And then you have until Saturday afternoon to do this. So that's basically 2.5 days or a little over 2 days to do that. All right, so I'll see you on the part 3 video. That'll finish up the test review.